Hi, thank you very much for that. Hi, again, my name is Ron Dombrowski. I work for the Way Companies here in Austin, Texas. First presenter we have today, his name is Ivan Peshikov. He is the project manager from an organization called American Air and Water. They are a UVC disinfection company that I've been doing some pretty good business with. Ivan is one of the smarter people that I've run into on the UVC side, and he's going to be giving you a presentation on the UV, on basically how UV works and some of the pros, some of the cons for it. He's only been doing this for about 15 plus years now. So everyone, say hi to Ivan.
Well, thank you, Ron. Thank you for the good words. Good morning. My name is Ivan Peshikov, and as Ron said, I've been with American Air and Water for a few years now. And I was invited to present to AFAME an overview of the germicidal UV technology and how it can be used to improve the indoor air quality and reduce the risk of infection spreading throughout the indoor environment. Of words about our company, American Air and Water. Specializes in research, development, marketing, and sales of air, surface, and water UV disinfection systems, also providing solutions for controlling the spread of harmful germs inside homes, offices, hospitals, laboratories, schools, and food plants, virtually any indoor environment. Does UV work? That's a question that I sometimes still get. Or rather, how we know that UV really works. Germicidal UV provides engineering controls to help improve the indoor environment and protect the occupants from environmental spread of infections. The microorganisms are invisible to us, so we need to have a really good understanding of the technology in order to make sure that UV does work. Germicidal UV is delivered in indoor settings by different types of UV systems. And to ensure that the UV systems are effective, we need first the correct UV system to be selected for each specific application. And second, the UV systems must be properly sized to ensure that they will perform as intended. Before going into further details on the types of UV systems available, let's see what UV is and how it kills microorganisms. UV is electromagnetic radiation with wavelengths shorter than the wavelengths of visible light and longer than those of X-rays and gamma rays. Regardless if UV is produced artificially or by the sun, the UV part of the spectrum is situated just beyond the violet end of the visible light spectrum. That's why we call it ultraviolet, or UV for short. Technically, UV is not a light because we can't see it, but the term UV light has become so popular that its use has been adopted by the UV industry. Most sources of light generate some UV, and the special lamps that produce germicidal UV radiation also generate some visible light. Even though the link between UV and light is very strong, the fact that we can't see UV is significant because it means that we cannot rely on our eyes to judge the power of the UV lamps. The germicidal part of the UV spectrum, also called UVC. The UV part of the spectrum consists of several bandwidths or spectral ranges in order of descending wavelengths. They are UVA, which is the long wave UV. This part of the UV spectrum causes tanning and permanent skin aging. The UVB part is a small but dangerous part of the UV spectrum. Prolonged exposure causes sunburn and could result in permanent damage of the skin and the eyes. Now we come to the germicidal part. The UVC part of the UV spectrum, also called shortwave UV or germicidal ultraviolet, includes a 253.7 nanometer wavelength, which is most often rounded to 254 nanometers. Germicidal energy at this wavelength is used for air surface and water disinfection. Overexposure to UVC causes skin redness and eye irritation, but does not cause skin cancer or cataracts. High-quality germicidal lamps used in the UV fixtures emit over 90% of their radiation at the 254 nanometers wavelength and do not produce ozone. The last part of the UV spectrum is the UVV, or vacuum UV, which has wavelengths shorter than 200 nanometers. If a UV lamp has a second spectral peak at 185 nanometers, then that specific wavelength breaks down oxygen molecules in the air and creates ozone. One note that I would like to make here, the UVA and UVB wavelengths are the wavelengths produced by the sun that actually reach the Earth's surface. The shorter wavelengths, the UVC and the UVV, are actually filtered out by the ozone layer of the atmosphere, and that's why UVC does not reach the Earth's surface. What effect has UV on germs? Germicidal ultraviolet inactivates and kills germs such as bacteria, viruses, and mold, and even a small UV dose breaks down the DNA or RNA of the microorganisms, which makes them unable to replicate. If they cannot multiply, they cannot form colonies or cause infections, so they become harmless. If the microbes are irradiated with enough germicidal UV, their cell membranes are disrupted and then they die. How to ensure that UVC is effective? For an effective UV application, we have to make sure that sufficient UV dose is delivered to the target microorganisms. The UV dose is a function of UV intensity and exposure time and is calculated by the following formula. UV intensity multiplied by the exposure time in seconds equals the UV dose. The UV intensity is found in the specs of each lamp, and it is reported at a distance of 1 meter. The UV energy obeys the inverse square law, meaning that it is inversely proportional to the square of the distance between the UV source and the target. So the intensity must always be adjusted for distance. The UV dose is the total germicidal energy per unit of area, a surface area, delivered over a period of time. It is often expressed in microwatt seconds per centimeter square because it is a direct calculation of the distance adjusted UV intensity multiplied by the seconds of exposure. It can also be shown in a shorter notation in millijoules per square centimeter, because 1 millijoule equals 1000 microwatt seconds. These are several examples of the required UV dosages for 1 or 2 log reduction of various microorganisms. When target microorganisms are specified for a project, we use this table, actually the complete version of this table, to choose the UV dose that must be delivered to the microorganisms. In recent months, the interest is focused on the coronavirus, naturally. The good news is that it is an enveloped virus, which is relatively easy to inactivate. The target dose for 2 log reduction of airborne viruses is usually between 6 and 8 millijoules per centimeter square. How do we calculate the UV dose? For example, if we are targeting the 8 millijoules, which is 8000 microwatt seconds per centimeter square for log reduction of envelope viruses, a 36-inch wall mount TB fixture shown on the picture here uses a lamp with rated UV intensity of 120 microwatts per square centimeter at 1 meter. So at a distance of 1 meter, the seconds of exposure for a UV dose of 8000 microwatt seconds per centimeter square will be calculated by dividing 8,000 by 120 the intensity of the UV lamp, which results in about 6-7 seconds, which is approximately 1 minute. So an enveloped virus will be inactivated by that UV light at a distance of 1 meter in approximately 1 minute. And also UVC adds up with subsequent exposure of microorganisms. If the microbes are not immediately inactivated, the UV dose increases over time until they are rendered harmless. Artificial production of UVC. UVC radiation is artificially produced by monochromatic low-pressure mercury vapor lamps. These lamps emit over 90% of their UV radiation at 253.7 nanometers wavelength, which, as I said, is often rounded at 254 nanometers. They're called monochromatic because almost all of their energy is emitted at a single wavelength, 54 nanometers wavelength. Monochromatic germicidal UV lamps do not produce ozone. Ozone is produced by UV lamps which have a second spectral peak at 185 nanometers wavelength. LED sources of UVC are being developed, but presently the UV lamps are still vastly more popular due to their low cost availability and effectiveness. Types of UV applications. UV applications, many different types, but for the types of facilities that you mainly work in, there are two main UV applications. UV lights for installation inside the AC systems for cooling coils and airstream disinfection is one of the main types, and the other is system which introduce germicidal UV directly inside the rooms. When UV is used inside the rooms, it can be for direct surface and air disinfection while there are no people present in the room, or it could be limited to upper air disinfection, which relies on the natural air convection and can be used 24/7 with people present in the rooms. In some rare cases, portable air purifiers can be used, which combine UV disinfection with air filtration. The germicidal UV energy can be delivered by permanently installed fixtures or mobile systems which are moved from site to site. Some special applications include UV in operating rooms or isolation rooms in hospitals. And here are different types of in-room UV fixtures. These include direct UV lights for wide area, direct surface and air disinfection, totally enclosed UV lamps with fans to force air circulation through the UV chamber, wall-mounted UV fixtures with louvers for upper air disinfection, and a type of system which originally were developed only for hospitals and laboratories, but are becoming more popular for schools and even office buildings today, is the mobile UV room disinfection system. These are used at times when the rooms are not occupied to disinfect the air and all exposed surfaces. A 400 square feet area, which is approximately 20 by 20 foot room, can be disinfected by a 12 lamp system in about 5 to 10 minutes. It is recommended that the room is exposed from more than one location to minimize the shadowing effect of furniture and equipment. And here is the other type of UVC systems for installation inside the AC systems. This could be special importance to you because I assume you have to take care of some of the AC systems of the facilities that you work with. So this type of systems include UV fixtures for cooling coil and drain pan disinfection, UV fixtures for airstream disinfection, which are normally installed in the air ducts, UV kits for PTAC and split systems, and modular UV system for installation in the air handlers. This type combine disinfection of the cooling coils with airstream disinfection. Back in 2003, the United States General Services Administration Office of the Chief Architect has incorporated UV in the facilities standards for the public buildings as follows. Ultraviolet light C-band lamps should be incorporated downstream of all cooling coils and above all drain pans to control airborne and surface microbial growth and transfer. Applied fixtures and lamps must be specifically manufactured for this purpose. Safety interlocks shall be provided to limit hazard to operating staff. UVC can help with energy savings. This application is reported to reduce maintenance costs, reduce pressure drop across the evaporator coils, and improve heat transfer of evaporator coils, therefore resulting in overall energy savings. The energy savings are also a result of improved airflow and reduction in required air handler energy. Because LEED certification points are based on strategies that will have greater positive impact on energy efficiency and carbon dioxide reduction, it is conceivable that deploying UVC coil cleaning technology would count for LEED credits. And indoor air quality. Microorganisms are not the only indoor pollutant, so germicidal UV must always be combined with air filtration, ventilation, and humidity control to ensure the best possible indoor air. The indoor air quality is adversely affected by bioaerosols, which are airborne droplets containing germs. These can be toxic and allergenic, but the biggest concerns since the beginning of the pandemic is the spreading of the coronavirus throughout the indoor air. Pathogenic bioaerosols can facilitate the environmental spread of infection from person to person throughout the indoor air. Aerosols larger than about 5 microns will propagate directly or would settle on the floor and surfaces. When I say propagate directly, that means that they can infect a person, direct person-to-person infection with after sneezing or coughing or even just by talking. And bioaerosol droplets smaller than 5 microns can become airborne and stay airborne for long periods of time, which increases the risk of environmentally transmitted infections. And these are actually the type of bioaerosols that UV can help with, because it can inactivate the viruses in them. Indoor germs are invisible until they manifest themselves. When that happens, it may be too late to try to fix the problem. And in this case, this slide shows a mold-infested room, which is not the main concern nowadays. The concern is coronavirus, so that manifests itself when people are getting infected. Everything may look normal on the outside of an AC system and in the indoor air, but many times the mold and other germs grow in the AC system itself on the coil and drain pan and are dispersed throughout the indoor environment. Cleaning the biofilm and mold growth from the cooling coil with chemicals is expensive, labor-intensive, dangerous, and ineffective. With pressure washing, the mold is impacted deep between the coil fins. UV provides economical, safe, highly effective, and virtually maintenance-free alternative. Properly sized and installed UV systems provide continuous, economical, and safe disinfection of cooling coils and drain pans, which are often the source of microbial contamination or help spread the pathogens throughout the building. UV reduces the indoor germs. Germicidal UV can effectively reduce or eliminate indoor germs by disinfecting the indoor air, disinfecting cooling coils and drain pans to prevent mold and other germs from growing, and also disinfecting various surfaces directly inside the room. This is the ASHRAE position document on airborne infection diseases, which includes UVGI, ultraviolet germicidal irradiation, as one of the engineering controls available to managers. And also ASHRAE gives top priority to further research on filtration and ultraviolet germicidal irradiation engineering controls to reduce infection disease transmission inside the building. Many universities have programs on ultraviolet germicidal disinfection. Here is a UVGI course by the Harvard School of Public Health. The Penn State University also has a popular environmental engineering program, which includes an extensive germicidal UV course. UV safety. Exposure to germicidal UV should be avoided always. However, germicidal UV does not inflict an immediate and permanent damage. And actually, the American Conference of Governmental Industrial Hygienists Committee on Physical Agents has established a threshold limit value for germicidal UV, which is 6 millijoules, and that is over an 8-hour period. This is interpreted as if high exposure over 8 hours at the highest eye-level irradiance or intensity found in a room. In those conditions, a 6 millijoule per centimeter square dose is reached over 8 hours of exposure to intensity of 0.2 microwatts per centimeter square. So the 0.2 microwatts per centimeter square is widely interpreted as the upper permissible limit of intensity at eye level. So in addition to improving the indoor air quality and preventing spread of infections indoors, UV also provide energy savings by removing the biofilm. Removing the biofilm helps to preserve or improve the heat transfer capabilities of the cooling coil. It can also remove the mold impacted between the coil fins, which reduces the load on the blower and therefore the energy consumption. Also, UV can prolong the life of the AC equipment. The main advantages of UV disinfection is because there is no need to handle dangerous, toxic, or corrosive chemicals. It is cost effective. It has a very simple maintenance. The lamps are usually rated for 2 years of continuous use, and they only need to be replaced after 2 years if they're not used continuously, as is the case in some in-room systems. Then a set of lamps can last even longer than that. No moving parts in the UV systems, and also UV provides immediate disinfection. And with this, I've pretty much concluded the part of the presentation that I wanted to talk to you about. Here I've presented a few UV fixtures that are representative to the different types of UV systems I've outlined earlier. This is a UV fixture that normally goes inside the air handler downstream of the cooling coil to disinfect the coil and drain pans.
Ivan, I have a couple of questions for you real quick. One of them from Barry. He wants to know if the UV systems break down things like belts, insulation, vinyl tubing, electrical wires, things like that, and what steps should be taken to protect those materials.
In most cases, UV does not penetrate deep enough into materials to inflict structural damage. However, some thin materials may suffer under UV exposure, and this is specifically plastics, which are not UV inhibited. Protection could be they could be spray painted with aluminum paint or covered with aluminum duct tape. This will provide complete protection against the UV.
Okay, another question from David. What is the best application, the UV application for elevators?
I've had a couple of inquiries for that specific installation. If the height of the elevator provides room for installation of direct UV fixture, actually we have a corner mount UV fixture with louvers, similar to the TB fixture that I showed earlier, that could stay on 24/7 and disinfect the air in that elevator. Or a more complicated system would be to put an unprotected UV lamp in the elevator that only comes on when the elevator is empty. And that type of UV fixture will disinfect all the surfaces and all the air in the elevator. However, that would require some kind of complicated sensors or setup to be able to tell the fixture when the elevator is not occupied, because UV cannot be used, direct UV cannot be used in occupied spaces.
Thank you, sir. That's all the questions I have so far.
Okay. These P-type UVC kits originally started as a smaller UV systems that can go in small AC system downstream of the coil. However, lately we've developed a larger modular type of these kits that can combine cooling coil with drain pan disinfection and airstream disinfection, and actually offers a very effective installation directly inside the air handlers. That has been the most popular type of installation since the pandemic started. This is an example of UV fixture that goes inside the air ducts to disinfect the airstream. Only the UV lamps and their supports are inserted in the air duct, and the chassis of the fixture stays on the outside. And this is a relatively easy installation. The only downside is it does not shine directly on the coil, so it does not disinfect the coil. This is the type of UV system that can go directly in the room with louvers. The louvers direct the UV rays above eye level, and the rooms can be occupied while the UV is on. And this is an example of the direct type UV fixtures that goes on the ceiling and can disinfect all the exposed surfaces and all the way down to floor area, but the rooms need to be empty. There cannot be people present in the room when this type of fixture is in operation. This is an example of a mobile system. This is a 12-lamp system. It can disinfect a 400 square feet area in about 5 minutes, and it needs to move from point to point, minimize the shadow effect. And this is the last example that I wanted to show you today. It's a large commercial portable air purifier that combines a HEPA filter that has capability to filter out 99.97% of particles as small as 0.3 microns in size. It has a 2500 CFM blower, and it also has 16 45-inch UV lamps, which disinfect that airflow that goes through the system. And I do have some slides which are specific for hospitals. I don't think I need to cover this today. So with this, I conclude my presentation. Thank you very much for your attention. If you have any questions, I would love to answer them now, or I can provide written answer later on. Also, this presentation with all the notes will be made available to you. So anything that you did not understand while I was saying it, you will be able to read it later on. Thank you very much.
Gary, there are.
Thank you, Ron. Yeah, thanks, Ron and Ivan. I'm going to go ahead and we're going to get Gary started. Thank you for your time, Ivan, and then we'll get your PowerPoint sent out. And I'm going to move you to the attendees section now.
Okay, thank you, Amy.
Thank you. All right, Ron, do you go ahead and let's, we're going to get Gary to share his screen.
Oh, here we go.
Hey, Gary, how are you?
Good. I think I finally pressed the right button there.
Cool. Everybody, this is Gary Graham. He's the Vice President of Sales for Global Plasma Solutions. He is the South Region's Vice President. He's based out of all places, Dallas, Texas. He has a great deal of experience in the ionization side of life, and he's going to present everything that, well, a few things that he knows about GPS, and hopefully it'll help. Thank you very much, Gary. It's all yours.
Thank you. All right, so I'm going to start, and I want to thank Ivan. I learned a lot, and believe it or not, I agree with everything he said. So very informative and great presentation. So let me share my screen. I'm going to start with just a little 3-minute video that we did. We're real proud of it because it's taken about a year to get our marketing people to put this together, and does a great overview. So are you sharing my screen? Let's see. Share screen. Let's try this. Are you seeing that?
Yes, we are.
All right.
Have you ever heard someone say, let's go inside to get some fresh air? Probably not, and it's for good reason. On average, we spend 90% of our time indoors. But according to the EPA, indoor air is often 2 to 5 times more polluted than outdoor air. In fact, many of the buildings we occupy could be harmful to our health without us ever knowing. Hidden molds, off-gassing from chemicals or furniture, even people are just a few of the sources that degrade indoor air quality. So it's no wonder we go outside for fresh air. Outdoors, naturally occurring ions are everywhere and are constantly working to clean the air. Ions are created with energy from rushing water, crashing waves, and even sunlight. Unfortunately, the concentration of these naturally occurring ions is much lower indoors, where particles are often suspended in the air. These particles can include dust, dander, pollen, smoke, and even pathogens such as mold, viruses, and bacteria. The risks associated with inhaling bacteria and viruses may seem obvious, but even common dust and dander can cause respiratory issues or worsen pre-existing conditions such as asthma and allergies. There's still hope for indoor air quality though, thanks to ionization. Our patented needlepoint bipolar ionization technology safely introduces ions into the airstream using the airflow in your existing ventilation system as the delivery method. When these ions disperse throughout a space, such as an office or a schoolroom, they combine with particles suspended in the air. This creates a snowball effect in which particles of opposite polarity begin to cluster together. As these larger clusters pass back through the building HVAC, they're easier to capture in the filtration system. Our cleaning process is also effective against pathogens, as contact with ions disrupts pathogen surface proteins, rendering them inactive. Other common indoor air pollutants include VOCs, or volatile organic compounds. There are hundreds of types of VOCs that are created by common household items, such as cleaning chemicals. Ionization is effective at eliminating VOCs as well as odors, such as those lingering around nearby trash. Through our patented technology, VOCs and odors are broken down into basic, harmless compounds, leaving the air smelling fresh and clean. You can also feel confident knowing that, unlike many other products, our ionization cleaning process will not introduce ozone or other harmful byproducts into the air you breathe. Today, our technology is trusted to safely clean the air in hundreds of thousands of installations, including offices, schools, airports, hospitals, and other community spaces around the world. So now, we can go inside to get some fresh air.
All right, we're going to move. Can you still see my screen?
No, you'll need to stop share and then share again. Whenever you switch screens, it wants you to share it again.
Okay, we can do that. Share screen.
There it is. You got it. Perfect.
All right. We always use Microsoft Teams, which is a little bit different, but pretty much the same. All right, can you see the GPS?
Perfect.
Ah, great. Well, you know who we are. We're actually the worldwide leader in needlepoint bipolar ionization. And the same way that UV has different types, UVA, UVB, UVC, high room. There's different types of bipolar ionization, and needlepoint is it's been around for about 20 years. We've been in business for almost 12 years now, and we have taken it from the original little matchbox to after 50 patents, we've become the worldwide leader. And we'll go through some of that. But we basically engineer electronic air cleaning solutions, and we do it using needlepoint bipolar ionization, which we'll talk about. And we do that to reduce the contaminants of concern. And those are really particulates, odors, and pathogens. And we call that POPE. And the last, the E, is the same as Ivan said. By using ASHRAE 62.1, we can lower outside air if you can clean the air of the contaminants of concern. And this is just one of our campaigns to breathe easy. This is in an arena that we did recently. And like I said, we've been in business for about 11 years, hundreds of thousands of installations in all different applications. A couple of our noted clients are the White House. We do a lot of higher education. Here in Texas, you can see SMU, North Texas. The last couple of buildings at SMU have installed us. They did it in lieu of UV. Most of the buildings on SMU campus had UV till a couple of years ago, and they tried us and they liked us. So we're in those now. We've done 7 or 8 buildings at North Texas this year. A&M, we're working with them right now. LSU, a couple of interesting projects down there. We did their veterinarian school. We also did their new indoor football practice field. And we just mentioned ASHRAE 62.1. If you use the normal ventilation rate procedure, they had to bring in 24,800 CFM of outside air. And even though it's a large space, there were only 200 people, maximum occupancy. And by using the indoor air quality procedure, you could technically lower that to 1,000. But because of pressurization with their exhaust fans and lockers, they ended up putting in right at 12,000, but less than half of what they would have brought in. And down there in Louisiana, where it's warm and humid air, the less air you can bring in, the better. So this is a photo of an installation on the front of some coils. And this is a large air handler. We can go either on the front side or the back side of the coils. Normally we like to go on the front if you want to keep your coils clean. And we found that especially on larger coils in hospitals, if it's a 6-8 row coil, that using UV, which has been traditional, it doesn't get in the center of these. So when we go on the front, our ions go through the coil and clean it from front to back. I'll show you a couple of coils that came out of a hospital that had UV that did a good job on the back side and the mold on the bottom, but there was bio growth on the inside. I think someone raised their hand. Was there a question? Okay. And ions actually help you stay awake and aware. And we found that in a lot of K through 12 and higher education. The University of Columbia did this study that said that actually ions help you stay more alert. Here's just a small list of some of the hospitals we've done. A lot of them here in Texas, Anderson Medical Center, Houston Methodist, Baylor. We do a lot of senior living. We do a lot of airports, both in Phoenix and Charlotte. We're flat spec'd. Anything that goes into either one of those airports will have our equipment in them. We're also the only technology that's been approved by the FAA to go into private and commercial airlines. And one of the tests that we had to do, this DO-160, was kind of interesting because you can't have any EMF line noise, which in hospital applications is important to make sure that you don't interfere with any of their communications or equipment. We have done, actually we're flat spec'd with Gulfstream, especially all of their service centers around the country. We just did 20 of the gates at DFW on their, what they call their PCAs, preconditioned air units that are at the jetways, and have been talking with all of the airlines on actually going in the planes. So a couple of things that are a little bit different than UV that we affect. One is particulates. And in the video you saw how when we charge the air as it goes through the system, we charge it, the air molecules positive and negative, then they attach to particulates and agglomerate and get bigger, so that it helps your media filters be more efficient. We don't eliminate filters. We're not a filter. But one of the things you'll find with particulates is size matters. And the smaller the particulate, the more danger it is. Our bodies do a real good job of filtering larger particles like PM10. Your mucous membranes and your nose hairs will be able to filter that out, and you'll sneeze or cough. But if it's smaller, it'll get down into your bronchial tubes, and if it's ultrafine, it'll get all the way down into the alveoli, which is a little membrane at the end of your lungs. It's covered with capillaries, and that's where your lungs exchange CO2 and oxygen. So you don't want to have any restrictions there or damage those in any way. And we'll talk a little bit about ozone also. That's one of the big dangers of ozone, is that it can oxidize or destroy some of the lining in your lung membranes. And another point I want to point out real quick is your body can exchange oxygen and CO2 at a rate of 50,000 parts per million. So if you inhale, when you exhale, 5% of the oxygen you inhaled is replaced with CO2. And you do the math, that's 50,000 parts per million. There are some engineers that want to limit the amount of CO2 in a building to 1,000 parts per million, but your lungs can exchange at 50 times that. So, and many authorities, OSHA, the US Navy, the NASA, allow their sailors and astronauts to breathe up to 8 or 10,000 parts per million of CO2 for 6 months. Back to particulates here. One of the things that we can do, and we've got a couple of studies that I'm happy to share with you. We've tested a MERV-8 filter with and without our technology, and using our technology with a MERV-8, it has the efficiency of a MERV-13. We did another study, or actually the National Research Council of Canada tested our equipment in a hospital in Western Canada about 6 months ago. And they found that we made their final MERV-12 filter as effective as a MERV-16. So I'm happy to share those. This is the one that was done here in Kentucky that showed that a MERV-8 was effective as a MERV-13. So that's particulars, odors, VOCs. We do the exact opposite that we do with particulates. And instead of agglomerating and making them get bigger so your filter is more efficient, we tear them apart. And very easy to understand. Every molecule can be broken down if you apply enough energy to break the molecular bonds. Ammonia is one that we're all creating ammonia right now. About 10.5 volts of electrical charge will break those bonds, and it'll break the down into just nitrogen and hydrogen. So,
Gary, we have a person with a question.
Okay.
The question is, if the ionization system attracts particles like viruses, bacteria, and does it get heavy and drop onto surfaces?
It can. It can. The most dangerous particulates are the ultrafine that you cannot even see. You can see them sometimes if in the early morning or afternoon with direct beams, but normally you don't see them. But those are the ones that are the most harmful to your lungs because they can get down all the way down to the alveoli. It can normally, when they agglomerate, your filter will pick them up. Some will get heavy enough that they'll drop out of the airstream, but most of them, in fact, if you will measure particulates before and then a couple of days after, you'll actually see more particulates a couple of days after we install, because those ultrafine particulates that most particulate counters can't pick up are actually getting bigger, and you'll see larger 2.5 volumes for like the first couple of days. Then if you'll test it in 5 or 6 days, you'll see a dramatic drop in them. But actually, your particulate counter will count more the first couple of days because they're agglomerating, getting bigger, and your particulate counter, unless it's an expensive particulate counter, the ones that get ultra fine are normally in the $5,000 or $6,000 range. The less expensive particulate counters won't pick up the ultra fine. But yes, some of them will drop out of the breathing zone, but most of them, especially the first couple of days, will be picked up by your filters.
Particulates that hit the surface, are they potentially hazardous?
No. They're a lot less hazardous there than in your lungs, I promise you. Here's some chemicals that we break down. And for instance, formaldehyde, that's just H2O with a carbon attached. And it only takes 10.88 volts to break down formaldehyde. Now, the bottom line, this is what's most interesting, that's oxygen, that's O2 that we're breathing. It takes 12.07 volts to break the O2 bond. And once you break that, oxygen's very reactive, and it will want to react with another molecule. And when it reacts with another O2, it'll make O3, and that's ozone. It's that simple. As Ivan said, normally you don't see that with UV unless you get to a stronger UV wave down into below about 220 nanometers. So normally you don't see ozone with UV. You could, but it's very rare. But the tube that's in the bottom there, that is one of the original bipolar ionization. You'll still see those in the market today. But the way that works, there is a positive lead inside that tube, and then the outside is grounded. And you have to put enough electricity in there to try and span whatever barrier that is, whether it's a glass tube or some type of a composite material. Either way, you have to put enough electricity to span that barrier. And when you do that, it creates a plasma around it. And these work. I'm not saying they don't work, they work very well. As the air goes across, it's charged positive and negative. The problem is it takes more than 12.07 volts to span that barrier. And when they do that, it's referred to as a corona discharge, and can make ozone and ROS and byproducts that you don't want. That is one of the things that we eliminated with our technology. With needlepoint, we can regulate how much voltage we put to our needle points, and can eliminate the ozone.
Real quick, just a question on the positive and negative ions that your system puts out. The thought process is, how reactive are these ions, and are they safe for people to breathe in?
Well, yes. I mean, nature makes them all the time. Anytime you have energy, you can charge ions. Now, an ion is simply an atom or a molecule that has one more or one less electron. And it's that simple. And molecules are exchanging electrons constantly. A visualization I really like is what happens in a electrical storm, a thunderstorm. As the air goes up, there's updrafts and downdrafts. And as the air is going up and down, they will exchange electrons. And normally you'll have a positive charge at the top of the cloud and a negative cloud at the bottom, and you get a strong enough charge and you'll have an arc, which is lightning. One of the things about lightning is that it's so strong, it actually creates ozone. But kind of what we do inside of an HVAC system is we create an electrical cloud that the air flows through. Same thing as an electrical storm. Did that answer your question?
Yes, I think so.
Okay.
Question for you.
A couple of things that you, pardon?
I have a customer that already has one of your ionization systems put in. He wants to know if, he currently has MERV 8 filters. Is there any benefit to going to MERV 13 with an ionization system?
Sure. Well, it could be. Whatever filter you have, we'll make it more efficient because we help it pick up, particulates. In Canada, we made the MERV 12 as efficient as a MERV 16, and they tested the MERV 12 filter, and it spec'd out exactly where it was supposed to be. And then after they turned our equipment on, they spec'd it again, and it went from about 75% to 95%. So of the particulates that it pulled out. So whatever you put in there, it's going to make it more efficient. Now, you can't overdo it with your filters. Some systems aren't designed for a MERV 13 filter or a MERV 16 filter. And if you install that, you're going to restrict your airflow. And if you don't have as many air changes and airflow, you actually, it's detrimental to your air quality. So, you could go from a MERV 8 to a MERV 16, and because your system can't circulate the air, your air quality is actually worse. So you have to look at your system, and you guys are the experts in that. So just a couple of real quick examples on VOCs that we did down at Houston Methodist. They have these big standby generators, or do, and if you'll, right above that's their outside air intake, and every time they crank these up, if you look at the graph, you'll see those spikes. This graph is before and after upstream, downstream of our equipment. So you can see how we knocked the VOCs down. And even that peak, that second peak, it wasn't noticeable inside. We've been down at Houston Methodist for about 8 years now. And we still do a lot of work with them. We just did a couple of new towers this year. Heliports in hospitals, same situation. This one is up in Chicago, but that's what we did at Baylor Medical Center here in Dallas. They had an issue with their heliport. Every time the helicopter would land, surgeons were complaining that they were smelling exhaust fumes, and we were able to mitigate that for them. Once again, here's an upstream, downstream of our equipment up in Chicago. Pathogens, Ivan touched on this really well, and we affect them a little bit differently. Your pathogen is has a core that'll have RNA or DNA, and it'll have a membrane on the outside and protein spikes. If you disrupt those protein spikes, which actually have a positive charge, and rupture that membrane, it leaves the pathogen inactive, so it cannot hook onto a host and infect you. A couple of things we were talking about that you guys probably have heard more about, control humidity. We want to control the humidity mainly because of particulates and aerosols, that if someone sneezes and it's below 40%, it'll help dry that particle, and the pathogen will stay airborne longer. If it's higher than 60%, it'll be heavier and it'll drop out and get on your surface. So the other thing is reducing static electricity. Since we have positive and negative, we counter any static electricity that's in a room. We reduce particles. And the neat thing that we like about needle point bipolar ionization, we're active. We actually go into the space where most of your air quality devices and technology is in the system, and you have to bring the air back. A couple of things we found, there's an engineering and architectural group up in Chicago that just did and I've got this if you guys want to see, they did a model showing someone in there, they did a floor plan of their office and showed someone sneezing and how it spread through the office. And none of that ever made it back to the return vent. It all stayed in. So even if you've got some great technology in your system, most of these pathogens aren't going to make it back. And those that do, you don't have to worry too much about it. The University of Oregon did a study actually at a COVID hospital, and they actually found the COVID virus all the way through the system, but it wasn't active. So it couldn't infect anyone by the time it got through the system. So what you need to worry about more is the pathogens that are actually in the space.
The ionization system, just to clarify, the ionization system itself does disinfect or does not, does it kill the virus in the airspace, or does it just make it the virus larger so it'll get through the filter?
No, it'll deactivate. It's going to deactivate the virus. Now, one of the things that, we're talking about particulates, they have found that the virus, especially, as small as it is, it can hitch a ride on particulates and get pulled back into the system. But the latest things that we have seen is by the time it gets back there, normally it's inactivated or becomes inactivated. You need to worry more about the active pathogens in the space. So, the biggest benefit that we have in a system is keeping the coils clean. At hospitals, what we've done for years and years, we've gone on the front of the coil so we can keep the coils clean from front to back and not have that bio-based get compacted in the center. So we've been doing that for years, but what we've been doing the last 6 months, we've gone back to the hospitals and we've installed downstream of their final filters. One of the things that we didn't touch on is a filter will filter out ions the same way it filters out particulates. So especially in a healthcare situation where they have final filters, we'll keep the coil clean, and we've done that for years, but we won't make it past their final filter, and especially in an OR, past the HEPA filter. What we did at AI DuPont Children's Hospital up on the East Coast, We did this a couple months ago. We've been working with them for years and years, 8 or 10 years, but they actually installed us downstream of their HEPA filter in their OR. And normally that's was kind of taboo. You didn't put anything downstream of your HEPA filter. But what they found was the particulates, depending on the size, if they were anywhere, from ultrafine to 2.5 to 10, we reduced those anywhere from 30 to 70% in the OR downstream of their HEPA filter. And we also reduced the VOCs and the bacterial growth in there. So we're most effective right now, and most people are wanting us downstream to get ions into the space to react with pathogens. So, and to react with the particulates. There's that coil. This came out of a hospital up in Fayetteville, Arkansas. We don't like to kiss and tell exactly where it was, but this was a hospital and they had UV on their coils. And to be fair, these are old coils. They'd been in there 18, 20 years, but there was a lot of accumulation in the center of those. Once again, we've tested pretty much against every type of pathogen. You kind of group pathogens into a group, but nowadays everybody wants to split off viruses and bacteria because they're totally different. Bacteria is a growing microorganism, and viruses, there's different theories whether it is living or not. I think Lysol puts on their can kills all living viruses or kills viruses, but most people believe that the viruses are not alive. You can inactivate them, but you're not killing them. But you can kill bacteria and mold spores. And recently we did, about 2-3 months ago, we actually were able to test for the actual COVID-19 virus. It was very hard. We were probably the first to get that, and that's because of our relationship with the Air Force and with aircraft. They kind of expedited our testing and kind of put us in front of everyone else, which we appreciated. But it actually did show that we can inactivate the actual SARS COVID-2. So I'm going to open this up. Ivan talked a little bit about clean versus dirty coils and your fan savings. This was the actual static pressure on one of those coils in the hospital for fire. So there wasn't a whole lot of air going through there. But I'm going to open it back up. Are there any more questions?
Actually, it looked like you answered most of them.
I missed that. Can you repeat that?
I don't have a means of actually getting them to in on this conversation.
Okay.
No more questions to be asked. If so, your contact information is on your PowerPoint, correct?
Yes.
And if you want, you can actually give your phone number or something if they have other questions for you. That I don't have. There's no one has an issue with that.
Yeah, you can contact me directly. There in Austin. HTS is our rep there. Those guys are very knowledgeable, but I'm happy to answer any questions or refer you to someone local if you actually want to have someone come look at your site.
Okay, Gary, thank you so very much. I really appreciate your time, and you all have a good one, and
Hey, thanks.
out there.
All right. You guys have a great day.
All right, bye-bye.
Bye.